Some animals, like fish, can break down and eliminate the compounds found in oil from their bodies. How does this happen? When a fish encounters oil, its body activates genes that help cope with the exposure. The activation of these genes triggers a chain reaction of processes in the liver and other organs, breaking down and removing oil-based compounds from the body. This ability is present not only in fish, but humans and other vertebrates as well. Every species has a unique set of behaviors that also come into play. For example, golden tilefish naturally burrow into offshore sediments. If the sediments contain oil, it triggers the fish's oil breakdown mechanisms. Additionally, the burrowing behavior tends to expose golden tilefish to more oil than fish that do not burrow into sediments. Scientists find that even though a fish's body can break down oil, the chemicals the oil breaks down into can still have negative impacts on the fish. The level of oil exposure may also be so high that it overwhelms the fish's ability to cope. For example, Gulf killifish, raised in water containing sediments from heavily oiled marshes, have lower rates of survival and less success hatching than their unexposed counterparts. Oil-exposed fish also have lower heart rates and smaller body sizes. Similarly, exposure to small amounts of oil in the lab, even for brief periods, negatively impacts the swimming ability of young mahi-mahi as they age. Though a specific cause could not be pinpointed, scientists found that skin lesions in wild game fish, like red snapper, were correlated with oil exposure for a short time after the Deepwater Horizon spill. There are many factors at play in the environment, making things less straightforward than in the lab. Because of this, scientists continue to use a combination of lab and field studies to understand how findings in individual fish translate to wild populations and communities of aquatic life.